I gotta talk to Miss Corinne about that.
Have any IB questions on it? So for second test, you can take home because
Oh,
we
Chapter 21 is linear modeling, and it's like I said, it's a pretty short chapter. There are only 5 sections. Today we'll talk about correlation, and I feel like a lot of this stuff, dare I say, is common sense. The correlation stuff we're going to talk about, but I don't think it'll be that bad. We'll get into Pearson's correlation coefficient on Monday, and then the line of best fit, like actually how to make it instead of just like eyeballing where the line of best fit is. Talk about the least squares regression line, linear regression, which is less scary than it sounds, and then interpolation and extrapolation, again, less scary than it sounds. So then today we will be talking about just correlation, and we'll have a step back. All right, so correlation refers to the relationship or association between 2 variables.
Okay, when I started seeing the bottom line filter, I was like, why did it like came to me?
When we talk about correlation, there are 5 different characteristics that we consider to describe it. So the first one is direction. A positive direction will have a general upward trend. A negative direction will have a general downward trend. And with upward and downward, we are referring to looking at these graphs from left to right, like as we read. So from left to right, if it's going sort of upward, we call that positive. If it's going downward, we call that negative. Now, if our points are just randomly scattered around, we say that there's no correlation.
Now I see where they got the positive and negative. It could just be
So I put all 3 different types down here, but I didn't label them. So which graph matches which description? Okay. So this first one, I hear you guys saying negative. It's going downward.
No.
Good, no correlation. And then the last one? You guys are all right. So in order, the graphs were negative, no correlation, and positive. Any questions on that first characteristic? So up next is linearity. A correlation is linear if the points approximately form a straight line. So if you look at those points and they look fairly straight, we can call that correlation linear. All right, so we've got two different graphs. One of these is linear, one of them is non-linear. Can you tell which is which?
Yeah.
Very good. The second one is linear. The first one, those points more make a curve. They don't make a straight line.
Isn't the first one graphing a square?
It kind of looks like it. I don't recall where I pulled that from. I did a lot of internet Google searching for these pictures.
Before
So, yeah.
bothered me.
Well, like for the second one, like Tracy is linear, but like can't we get that?
Well, that's a good question. All right, so Shreya said, doesn't this one look like it's also positive? And that's absolutely true. A lot of these words go together, so you won't always use just one. It's going to be even more true on another one we're coming up. So,
It'll be like linear, positive.
yeah, and like this one, we wouldn't, I guess you could kind of call it positive, but we don't normally look at that. But yeah, this one's linear and positive. So these relationships, these correlations will have more than one description, more than one like characteristic describing them. All right, so yes, we said the first one was non-linear, the second one was linear, so we're all good on that. So we can also talk about the strength, and on these three graphs, you can see that a line was drawn, so they're all linear, like we said. Now we call the strength strong, moderate, or weak. And that depends on how close the points are towards that line. Like if they're closer together and closer to the line, that'd be strong. If we still follow that linear pattern, but we're kind of spread out a little bit, that would be weak. So I tried to mix these up. But can we tell which one of these is strong, moderate, or weak? And it's probably easiest to decide strong and decide weak because what's in the middle is going to be moderate. Yeah, what do you guys agree? Yeah. And for me, I think strong is the easiest one. I'm like, okay, this third one here is strong. They're all really close. This is the most spread out one in the middle, so that one's weak. And yep, moderate. Now, these three all have something else in common. Aha, they're all positive. So they were moderate positive, weak positive, and strong positive. So a lot of times we use those two words together, the strength and the direction. What? Yep, they're all linear as well. And then just to give you guys another visual, these ones here are strong negative, moderate negative, and weak negative. So just to kind of let you guys take a look at that as well. So then we might have outliers, and outliers are just a little bit different than the outliers that we had talked about last chapter. The outliers are still isolated points which do not follow the trend formed by that main body of the data. So if it's trending upwards, it'd be a point or points that aren't like with that trend. Yep, a couple points out there. Not with the rest of it. Now, this one was slightly throwing me for a loop for a second. Which one of these scatter diagrams has an outlier and one of them does not? So, which one? I know one has a line on it, one doesn't. But yeah, good job. So if we did draw a line on this first one, this point is not with the trend. Now, for a second, like I kind of thought maybe this one might be, but you see how it's still pretty close to the line, and even though it's spread out, it's still along the trend. So I just wanted to make sure we made that clear. So again, that first one has an outlier, and the second one doesn't. So just kind of keeping that on there. Now, one thing to note that if an outlier is a result of a recording or a graphing error, then we should discard it. But if it's a genuine piece of data, we should still keep it. If it's some kind of strange error, we get rid of it. But if it was legit, we want to keep it. We've got one more characteristic left. Any questions on outliers? So the last one is causation, and I pulled a quote that was like drilled into my head my freshman year of college by my like Psych 101 teacher. Correlation does not necessarily mean causation. Have you guys heard that before? Like in some, I know some of you take psychology, but not all of you do. So just because you've got some correlation, like you apply your points, you measure some things, you have your scatter diagram, it's looking positive, it doesn't actually mean that there has to be a cause there. It might not be the cause. Now, the only thing I could think to really give you for notes is to say that you gotta think critically about the situation. And there are two examples in your textbook that I'm going to turn to and summarize for you. If I can get to that page. So there was one like study that looked at the arm length and the running speed of a sample of children. So there's a strong positive correlation. So does it mean that if you have short arms, like there's going to be a reduction in running speed? Does it mean that if you run fast, that your arms are going to grow really long? Like, we got to think, right? We got to think critically about this. Right. Right. So think about it, because if we're talking about small children, as they get bigger, their arms are going to grow and they're going to get faster, right? Like as they grow older. So it might not be that the long arms are causing the running, or the running is causing the arms to go longer. Another example said they studied that there were more television sets sold in one town. At the same time, there were more stray dogs. There's positive correlation there. They have nothing to do with each other. All right? Right. So I'm just saying that you got to think critically about these. Now, if it truly is a situation where a change in one variable causes a change in another, we call that a causal relationship. So, of these 5 characteristics, which do you think is the most difficult to describe or determine, and why? So this is another bit of self-reflection, like what's going to maybe be your weakness in this section. I don't know if does anyone have anything that's popping out to them? The causation, definitely have to think critically about that. Besides causation, for me, it's the strength, because like when I look at moderate and weak and strong, like sometimes I think it's not like so definite. We're going to have some more, like not tomorrow, but Monday when we talk about Pearson's coefficient, we'll actually put some number values to it. But for right now, we just kind of have to eyeball it. And that's where, when you're doing your assignment, double check your answers. Because there were some of them where I was like, oh, I think that looks weak, but then they're like, actually, it was moderate. So double check those answers. That doesn't mean turn to the back of the book and write down the answers. It means do your assignment and check your work.
Oh, look at that face on
On who? Oh. Okay, so there is a lot of graphing, like of scatter plots. So I do have that grid paper that I had out last week if you guys want that. And it's true, you can also, there's a note in your textbook that you can use graphing calculators to make a scatter plot. But if you do, like if you own a graphing calculator and you're using your graphing calculator, please make sure you include a sketch on your assignment. And if you need like help with the TI-84 for that, just let me know. So let me know. Just a sec, okay?